This is a short introduction to streaming with Apache Spark. You may want to use streaming architectures when your data arrives incrementally over time, as opposed to all data being available, let's say, in large chunks of Parquet files, like you would do in data analytics. In previous lectures, we have seen data frame API. Spark has an extension to it called structure streaming that allows you to process streaming data and handle both sources and sinks. I refer to the diagram here on the slides. You have sources on the left. Apache Kafka is a very popular source of streaming data. Then you have file sources where, for example, you have a folder where new data comes in one of the many formats that Spark can ingest. You can also have custom sources. Then Spark sits in the middle with the data frame API and structure streaming. And then Spark handles the sinks, again Apache Kafka. Then there are file sinks again, like Parquet or Delta Lake or the other data formats that Spark can handle. And then it's also possible to sync into memory, typically for demo purposes. We will use that. The most important abstraction when dealing with data frames and Spark streaming is the concept of unbounded table. Data frame is the abstraction in Spark that maps tables. And when we are using streaming, new rows appear in the data frame as if the table has no boundaries. So we'll have new data and the data frame keeps growing. Let's say every 1 second new input data comes in, then some processing is performed, and the results are written out into a sink. There are many different details and options for this. I refer you to the documentation. So when doing data analysis with batch, you will use Spark Session.read and then a format, let's say CSV. And then in this case, you also specify some other options and sample the schema here. And then we'll point to a folder where the data is stored, and you do load to load the data into a data frame. When we want to map this into the streaming context, the changes are small. We just change read for read stream. And then in this case, we are reading again from CSV, so file, a data source. And this allows us to read an input stream. Okay, the next step is to do some processing with this input stream that comes in. We can, for example, do a filter, which is a stateless operation, or we can do more complex stateful operations like count or aggregations. Again, here in the example, you see Spark read stream, format CSV, and then we filter this input stream, applying a filter column 1 equals 1. Finally, we want to write out this input stream after the processing. So we take the input stream filtered and then we do write stream and we start writing it. We'll use output mode append, format memory, basically for demo purposes. In real life, you will use typically different sinks, and we'll see one in the next slide. And then very importantly, we apply start. This starts the full pipeline because before we just defined the concept of input stream as a data frame and some filters. We define the processing and transformation that we want to have. And now with start, we want that the pipeline starts and Spark starts looking at the data in the input path and searching for new data as it arrives over time, applying the filter and also writing out into our memory sink. Kafka is a very popular tool used in the streaming context and is very well integrated with Apache Spark. When using it with Apache Spark, we'll need to point Spark to the Kafka servers, subscribe to a topic, and then handle the key value pairs that arrive. And then there are also other configurations that are not covered here. In this simple example, we just look at the basic of how to interact with Kafka. So we'll have the Spark session, in this case called Spark, read stream, format is Kafka. Then we point to the Kafka servers, host and port. Typically you have more than one for high availability reasons. And then you subscribe to one or more topics. I refer you to Kafka documentation for the details of what this means, and then you can have an offset where you want to start the reading. And this defines your input data frame. And then as data comes in, you need to cast it into the data types that you want to operate. Alright, this is reading, and then you want to write. Let's say if you're doing data enrichment, you will read from Kafka and write again into Kafka. This is something that many do, and also is done at CERN, for example, by the monitoring team. If you want to use Kafka at CERN, by the way, you can point to this URL here and you'll find a managed Kafka server. Okay, let's see an example of how you can write out into Kafka. So you will have the input stream with some processing typically applied to it, and then you write the stream, and the format is Kafka. You point to the Kafka servers, you define the topic, the output mode, and then a checkpoint location needed for restarting the writes. And then the start again is very important to start the full pipeline. This brings us to our key learning point for this short lecture. So Spark Structured Streaming extends the data frame API, and you can use it for building data streaming pipelines. The data frame API brings to the streaming fault tolerance and scalability. Spark supports many sources and sinks, and most notably supports Apache Kafka. Streams are mapped in Spark as unbounded tables using the data frame API and the structured streaming extension. And Spark will keep your data frames updated as new data comes in. After this lecture, I invite you to go and play the video of the streaming demo.